everyone, this video would show the easiest way to simplify radicals with variables, and this is the fourth part. In this part, our radicand is in fraction form. Before we go further, please feel free to check out the description below for the link of the other series of topics related to simplifying radicals with variables. Before we jump into this example right here, let's have a review on the parts of radical expressions. Please remember that these are the parts of every radical expression. The first part is the radical symbol. The reason why this is called radical expression is because it is an expression that contains the radical symbol. Our a here is called a coefficient. A coefficient is a number multiplied to the radical expression. And the letter n here is called the index. This tells you which root you're looking for. Please remember that if the value of the index is not written in there, it means that that invisible number is 2. We also have a letter C, and this letter C is named as the radicand. A radicand is the value that you are taking the root of. So this expression that we have here is read as A times the nth root of C. Okay, so we go over the problem here. So we are given the square root of 68x cubed y over 17xy. Now, please notice that our radicand is a fraction. And we also remember that the invisible index that we have here is 2. So again, if the index is not written, that is invisible 2. So I go ahead and go over the steps. The first step is to expand the given expression. So I go ahead and expand this. So this would be the square root of this 68 can be expanded into 17 times 4. So if we multiply 17 and 4 together, that would be 68. And then I'm going to expand this x. So there's going to be 3 of them. So that's 1, 2, and 3. And there is 1 y. So I go ahead and expand the denominator as well. So we can expand it further. So it's pretty much just 17 x and y. So what are we going to do is we are going to cross out those that we can cross out. They become a giant one. So in this case here, we have 17 and 17 can get crossed out. We have an x and x can get crossed out. And we have a y and y, they can get crossed out as well. So we are left with, that's going to be the square root of, the leftover here would be 4 and the 2 x's, and the leftover on the denominator is just 1. So I go ahead and write 4x and x. So we are going to expand this further. This 4 here, we can factor it out to its prime factor, or we can expand it to its prime factor. So that would be 2 times x times x. Now our next step is to group together the expanded form based on the index. So our index again here is invisible 2. So again, if it's not written in there, that's invisible 2. So we're going to group them into groups of 2. So there's 2 2's here, and then there is also, there are 2 x's here. So whenever we group them together, we write it outside the radicals. So this would come out one group of 2, and then there's another group of x. So I write x right there. Now inside the radical, nothing is left here. It's actually invisible 1, but we don't have to do that because square root of 1 is just 1. So again here, nothing is left inside the radical, although it's invisible 1, but technically nothing is left in there because we pair them up. So we therefore could say that the expanded or the simplified version for that is 2x. So this is again our simplified form of this expression that we have up there. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, in order that we can simplify this, the first step is to expand the given expression. So I'm going to go ahead and write the radical symbol right here. And I am going to expand the numerator and the denominator. So this is how it's going to look like. We're going to start with 32. So we're going to expand 32, or we're going to expand it to its prime factors. So I'm going to go ahead and show that work on the side here. So that would be 32. So that is divisible by 2. That is 16 times 2. 16 is divisible by 2. That is 2 times 8. 8 is divisible by 2. And that is 4 times 2. 4 is divisible by 2. And that would be 2 times 2. So these are the prime factors of 32. So I'm going to go ahead and write that on the numerator up here. So these are the prime factors of 32. So there's like 5 2's. And then I'm going to expand this x to the 6th and y to the 9th. And I'm going to expand as well the denominator here. So that would be 2 times 2. That makes up 4. We have 1x. And then we have 2 y's. So I am going to go ahead and cancel out the numerator and the denominator, or simplify it. So this would be 2 and 2. We can create a giant 1 from that. And then that's 2 and 2. So we also have an x, and we also have a y and y. So I go ahead and write the leftover. Okay, our next step is to group together the expanded form based on the index. Now, we remember that our invisible index here again is 2, because it's not written in there, and that should be 2. So we group together groups of 2. So there's gonna be 2 2's here. We also have 2 x's. Then we can come up with another group of 2 x's. We have 2 y's. We have another 2 y's here and another 2 y's. So I go ahead and write these groups of 2 x and y outside the radical symbol. So this would be 2. And then we have another group of x. We have another group of x. And then we have another group of y. And there's like 3 of them. So what I did here was that this represents the 2 groups of 2, the 2 groups of x. This would be the 2 x's. This is the 2y, the 2y, and the 2y. Whatever is the leftover, I write it inside the radical. So that would be 2 times, there's 1x, and then there's also 1y. So I go ahead and simplify this. So this would come out 2. There are 2 x's, so that's 2x squared, and that is y to the 3rd, and then the square root of 2xy. So this is the simplified version of this given expression that we have up there. Did you get the same answers as this? Good. Perfect. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so let's go over the problem here. We can actually rewrite this given expression right here as this cube root of, that's gonna be the numerator, x to the 9th. That's the cube root over, that's gonna be the cube root of 8y to the 6th. And again, this is one of the properties of radicals. So what we would do next here is to expand the given expression. So what I would do is I will expand this first one right here, the one on top. So I'm going to go ahead and write 9x's. And then I am going to expand as well the denominator. We are going to expand first the 8 to its prime factor. So I'm going to go ahead and show that work on the side here. So that is 8 would be divisible by 2. So that is 2 times 4. And 4 is divisible by 2. So that would be 2 and 2. So these are the prime factors of 8. So there are 2's. So I'm going to go ahead and, there are 3 2's. So I'm going to go ahead and write that down here. So that would be 2 times 2 times 2. That represents the 8. And there's going to be 6 y's. Okay, so this is the expanded version of this expression here. Now, what are we going to do next is we are going to group together the expanded form based on the index. Since our index here is 3, I'm going to make a group of 3x's, and then we also have another group of 3x's, and then another group of 3x's. And then for the bottom here, we have a group of 3 2's. And then we are going to create a group of 3y's and another group of 3y's. So then we can go ahead and simplify this further. So this would come out. So we remember that every time we get a group of 3, since this is a cube root, we write it outside the radical symbol. So on top here, we have one group of x, one group of x, and then one group of x, and nothing is left inside the radical because we group them all together, so we don't have to write that radical here. So although we can go ahead and write that as a square root of 1, because actually technically 1 is the leftover there, but then we don't have to do that. So we also have here one group of 2, and then another group of y, and then another group of y, and then nothing is left. So pretty much this expression that we have right here can be written in its simplified form as x to the third, because there's like 3x's and nothing is left inside the radical. And then we have 2y squared. So this is the simplified version of this expression that we have up there. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!